In December 14, 2020, Google across the globe suffered from an outage that lasted 45 minutes. Nobody could access most of Google's services. Google has released a detailed incident report discussing the outage, what caused it, technical details on their internal services architecture, and what did they do to mitigate and prevent this from happening in the future. In this video, I want to take a few minutes to summarize the report and then go through the detailed analysis. You can find YouTube chapters to jump into the interesting part of the video. Pick up your favorite drink, sit back, relax, enjoy, and let's get started. Let's start with an overview of how Google ID service works. The client connects to Google authenticated service to get authenticated or retrieve account information. The account information is stored in a distributed manner between the different service IDs for redundancy, and these are propagated with the Paxos protocol. When an update is made to an account on the leader node, the existing data in all the nodes are marked as outdated. This is done for security reasons because let's say you updated your account credit card, privated your profile, or deleted a comment, it is extremely dangerous to serve those outdated information. This was key to the outage. So let's pay attention to this one. The updated account is then replicated based on the Paxos consensus protocol to all the other nodes. The user ID service has a storage quota controlled by an automated quota management solution. When the storage usage of the service changes, the quota is maintained accordingly, either by reducing or increasing the quota based on the demand. So what exactly happened that caused this global outage? In October 2020, Google migrated their quota management to a new system and registered the ID service with the new system. However, some parts of the old system remained hooked up, specifically the part regarding the reading of the service usage itself. It was hooked up to the old service, and because the service is registered to the new system, the old quota system reported zero usage, as it should, because nobody's using the old system, right? So when the new quota management asked its service for its usage, it was incorrectly reporting 0. Nothing happened for a while, since there was a grace period before the new management system kicked in, but eventually, that grace period has expired on December, and that's when we actually started to see the effect of this. That's when the new quota system kicked in, and so that the ID service has a 0 usage and says, okay, why are you having 0 usage? Like, you don't need all this beautiful quota, so let's start reducing the quota that you have because you're not using any. That's the problem here. The quota kept reducing and reducing and reducing until the service had no space left. And that caused updates to the leader nodes eventually to fail, which, back to our original statement, caused all the data to go out of date in all the nodes, which in turn escalated globally to what have we seen. So now, let's jump to the actual report and start reading and analyzing this thing. Thank you so much, guys. If you're here for the summary, thank you so much for watching. And how about we go jump into the detailed analysis and read this thing and discuss. So guys, Google finally took the time to write a detailed incident report of what happened on December 14th, last Monday. So, quick summary, Google authentication services went down, and it went down hard. I mean, globally. So, for 47 minutes, 47 minutes, 47 دقيقة went down. So we couldn't authenticate. If you already logged in, you might get away with it sometimes, but that eventually failed. And if you want to log in, that is just done. You cannot log in. So that means most of the services actually went down. So how about we read this incident report and then start discussing all the different points. There's some lessons that we can extract from this as backend engineers. But in my opinion, the scale that this is, it's very unique to Google. So hardly any of us backend engineer will ever work on a project that is this big to run into this particular problem. But it just tells you that the amount of stuff that Google is dealing with is just, this is amazing. There's a lot of work. There's so much moving pieces, and of course you have to automate this stuff. So there are a few lessons that we can extract from this. How about we jump into the incident and start reading and then start understanding what happened. So let's read the issue summary. On Monday, 14 December 2020, for a duration of 47 minutes, customer-facing Google services that required Google OAuth access were unavailable. It's very interesting that they say customer-facing Google services. So that means they have an internal-facing Google services that did not suffer from this. That's very interesting. And that tells you that they have different code management for their internal, completely different. All right. That require Google Auth access were unavailable. Cloud service accounts used by Google Cloud Platform workload were not impacted and continued to function. All right, that's very interesting. If you have a cloud service account, you were not affected. So it's only Google OAuth access. We apologize to our customer whose services or businesses were impacted during this incident, and we are taking immediate steps to improve the platform performance and availability. Let's go to the root cause. What caused this thing? Obviously, I summarized that stuff, right, for you guys in a hurry, but we want to dig deep and try to extract more information if possible. Let's do that. The Google User ID service maintains a unique identifier for every account and handles authentication credentials for OAuth tokens and cookies, right? The cookies for existing, obviously, authentication, right? And tokens for non-cookie based, right? I guess the tokens are in the cookies per se, right? Unless this is different. It stores account data in a distributed database. I'm guessing Spanner, because that's the database I'm aware of that Google uses, which uses Paxos protocols to coordinate updates, right? This is one of the things that I'm seeing repeated, and I need to make a video on it and first learn what it is about, and then make a dedicated video about the Paxos protocol. So one of the gossip protocols, right, that can chat between different services and propagate the updates. Very, very critical. We saw that Amazon did not use these gossip protocols. Right? They had like some sort of a peer-to-peer architecture, which did not scale compared to this. This is good. I mean, Paxos, as we know it, from what I read, it's something that scales essentially, right? Because it doesn't really update, it doesn't really connect every service to every single service. That's just peer-to-peer, and that doesn't scale much. For security reasons, the service will reject request when it detects outdated data. So they did not say why, but I just suspected, and I actually think 19% sure that this is by design, obviously. And the security reasons is, let's say you updated your security profile, you added a new credit card, or you removed an existing credit card, or you have deleted your account, or you have privated your account, or you deleted certain comments. You remove something that now you're trusting the system to actually not show that, right? It's very critical. You will lose the trust of the system if the system, you just turn around and deleted something and you refresh and all of a sudden it's there. That's bad, right? And Imagine this happens to your tweet, for example. You delete a tweet and it's still there, right? Especially for celebrities, this is big news, right? It's like, oh, I deleted it. I mean, screenshots exist, but regardless, they just want some, some trust in the service, the system. Google uses an evolving suite of automation tools to manage the quota of various resources allocated for services. As part of an ongoing migration of the user ID service to a new quota system, a change was made in October to register the user ID service with the new quota system. Right? So they had a new quota system that allocate the space and usage, right? We talked about that in my first video. I accidentally said disk. They ran out of disk space. Obviously, that was dumb of me to say that, right? They never run out of disk space. They just, a quota assigned to the service itself was insufficient, right? That's what happened. So now, that changed. They migrated everything to the new system, but parts of the previous codes were left in place, right? So that's what I started guessing, because they didn't say. Incorrectly reported the usage for the user ID as service. Again, they didn't mention why, but it's clear once you start thinking about it. Well, you register the user ID service to the new system. That means the service is no longer using this old system, right? The old quota system. So if the old quota system has been asked, hey, what's the usage for this service ID, right? It will say, this service is not using any of my quota. It's 0. Because you just registered it. So the question of what is my usage were incorrectly being asked to the incorrect service system, let's say, the quota system, right? But the quota question, how much quota is assigned, is asked to the new system. That's what my guess. That's what happened, I think, right? Let me guys know what you think about that, right? So that's what happened, right? So let's summarize this. Now we have two systems: the new system with the quota management and the old system. And we have the user ID service. The user ID system is the user ID service is registered with the new quota system, and it has a quota and it has usage in the new system, but it also remained hooked up to the old management system, the quota management system. So now if you ask the question, how much quota is assigned to the user ID, the answer will come from the new quota system. Will say, hey, I have 80 terabytes. Obviously, it's more than that. But if you ask the question, how much usage this service has, that question will go to the old system. And the old system will say, what are you talking about? This service is not using any of my quota. So 0. Again, that's a guess. An existing grace period in enforcing quota restrictions delayed the impact, right? So they had a grace period. So they implemented this in October, but there is a grace period apparently. Well, because we hit the quota, right? If you think about it, hey, you are using 0 and you're allocated this much terabyte of data. Why? So the system actually detected that immediately, but it was given a grace period all the time. I said diamond. all the time. There was always a grace period for everything. Nginx shutdown grace period, right? HA proxy shutdown grace period. Process lingering grace period. There's always a grace period. It's like, okay, I'm not gonna kill you right now. Let me give you this much time, and then I'm gonna take action, right? It's like when you're late on your loan payment or something. It's like, okay, I'm gonna give you a grace period because we're banking and we're good people, so we're gonna give you a grace period of 14 days before we put you in jail. All right, so which eventually expired, and here's the first thing, right? Here's the first thing that raised my alarm when I read it. It's like, okay, when we first detected this in October, the system did not raise an alarm that this service has exceeded its quota. It should immediately have detected that and showed it, hey, by the way, this service is in a grace period. They did not have any alerts for that particular case. I guess after reading this, you will know why. They didn't consider a service usage of 0. which is interesting if you think about it. Because like, how do you think you a service will use something, right? It's impossible for a service to use zero, right? I guess that could happen. Again, which have enjoyed experiment. Triggering automated quota systems to decrease the quota allowed for the user ID service and triggering the incident. So that's what happened, right? So we detected, okay, oh, your grace period is done. You're using zero, obviously. So no, nothing for you. Come back 1 year, okay? And then took all of the quota, took all the quota from the poor service ID. It's so sad. Existing safety checks exist to prevent many unintended quota changes. So there is unintended quota changes. They had alerts for this and safety checks, but at that time they did not cover the scenario of a zero reported load for a single service. Right? It is fascinating, right? And it seems like a very small error if you think about it. It's like, yeah, I just didn't anticipate that as usage is going to be zero. Whoever wrote the code for the automated system didn't anticipate that. Quota changes to large. Here are the checks that I have. Checks. Quota changes to large number of users, since only a single group was targeted of the change, right? So they have a change quota changes for a lot of users at once, right? Lowering quota below usage. So if the quota was lowered below the usage, right, then they will activate an alert. But guess what? How would you lower a quota below zero? It's impossible. So the alert will never be triggered, right? Excessive quota reduction in the storage system, since no alert fired during the grace period, right? So that's the problem, right? So there was like an excessive reduction in storage systems, like from whatever terabyte or maybe petabyte down to zero. That's excessive load. So this, they should have a measure to detect that, right? Apparently, no alerts were severed in the grace period, which is from October to December, 2 months. This went 2 months without being alerts. But still, you guys, even Google's not perfect. And I'm glad, I hate to say that, but I'm glad this happened because this kind of unveils some of the infrastructure in Google, and we, back in engineer, can learn a thing or two from this. And I love this stuff because we don't have access to any of these giants architecture internally. So these incidents kind of exposes some of this architecture and let us smell and taste, and we love to taste these different stuff. Low quota, since the difference between usage and quota exceeded the protection limit, right? If there's a low quota, there should be another alert as well. As a result, the quota for the account database was reduced, which the account database, right? So where you store the account itself, right? The database that stores everything about Google account, or just reduced, which prevented the Paxos leader from writing. Now you might say, Hussein, when I sign in, I don't write anything. I just want to sign in. Why would that fail? Right? Imagine, guys, something happened in the beginning. Of course, everything succeeded, but people started writing, and those writes started doing an amplification, write amplification, which just blew up. And obviously, since you can't write, sometimes the database will do decisions. Say, okay, I can't write. Reads will fail as a result, right? So Paxos leader. This prevented the Paxos reader from reading, which is writing to the main load, which then propagate. Shortly after, the majority of the read operations became outdated, which resulted in the errors of authentication lookup. So that's what we said, right? Because all these nodes have account information and they will go stale after a while. Now, I'm not sure if there is some sort of an expiry information on the account and they have to periodically fetch information from the database to stay fresh. If that's the case, then that makes sense. And if I didn't touch my account, why would that fail, right? That I don't understand, right? Because I didn't update my account. I didn't touch anything in my account. I just want to sign in. Why would that particular thing fail, right? Because the leader is not writing anything. The leader is just asking to read. So unless there is these nodes periodically read from the database to pull information about the latest account, because you could have read something right in the database. The other information is like if you write something, that definitely the leader will tell all the nodes, hey guys, whatever you have is garbage. Toss it. That I understand that one. What I don't understand yet is what if I don't update? Right? I'm just reading. Right? My information is still good. Right? Why would I toss it? This sounds like something I need to dig more into, or maybe from someone from Google can explain this a little bit better to me. Remediation and prevention. The scope of the problem was immediately clear as the new quotas took effect. That this was detected by automated alerts. So eventually alerts has fired, but what kind of alert? For capacity at 2020 December 14th at 3:43 in the morning US Pacific, right? I was asleep, obviously, right? Because I'm California, so I didn't feel any of this stuff. And for errors with a user ID service starting at 3:46 a.m. Right? So it took 3 minutes. So after 3 minutes, we saw other errors. People trying to sign in fails, right? Which paged Google engineers at 3:48. I like that actually took 2 minutes to page them. That's pretty quick if you think about it. Within 1 minute of customer impact, right? Immediately. At 4:08 in the morning, the root cause and the potential fix were identified. Damn, those guys are good. Immediately, right? They went there, they were paged. I guess they don't have to drive to Google. They just sign in, I guess, from their homes, right? And it took what? From 48 up until 08. That's doing the math. 12 minutes. Took almost 20 minutes. Yeah, so 20 minutes to identify and have the fix available, which led to disabling the quota management enforcement in one data centers, right? This happened in all data centers, right? That's kind of scary as well, right? How did this thing propagate to globally? If it happened to one data center, that's good, but that thing just propagate globally. So it had been there for months. So what the Google engineers did, they just disabled quota enforcement. They said, hey, no quota anymore. You guys can run free. So the service says, oh, I'm free, finally. So, and then it's like they started using without any enforcement. This quickly improved the situation, but there's obviously the backlog of requests that is failing, and there's like a sleuth of requests, right? That's why if you have a failure, if there's a request that fails, you need to tell the user as much as possible, as fast as possible. That's why timeouts on the server side and the back end are very, very critical, right? If you feel that the service is just spinning, or the request is trying to do something like the write, like imagine I'm writing and I'm waiting for the database to free, and that's a bad practice, right? If you're waiting for the database to free up in order to write, right? And if this is happening a lot, imagine having 1 million, 2 million, 3 million requests that all wait. That will just amplify. And even if you bring your database back, you will have no possible way to serve all these demanding users. So that's why quick failures are very, very critical in the backend in certain situations, obviously. It's not great for user experience, but Google knows this. Like return 500 error as fast as possible in these situations are very, very critical. So they disabled at 420, they disabled the quota management system. This quickly improved the situation, and 427, the same mitigation was applied to all data centers, which returns error rate to normal levels by 4:30 in the morning. That's when I think when I woke up. I woke up at 5 in the morning, and it's just like I saw like people. It's like, Hussein, make a video about this. You have to make a video. Like, well, what? Google went down. I didn't even notice. So if I woke up like half an hour before, I would have felt it, and I would actually have more insight. But thanks to you guys, a lot of you actually gave me input, like what exactly happened. Like, oh, I can open YouTube. I can open YouTube in incognito mode, but I cannot open it in when I sign in, right? And then comments are sometimes appear, and comments sometimes they don't appear. So this kind of gives me some hint to make the earlier report, but everything now almost makes sense, right? When you read this report, that kind of line up with you guys reports and incidents. As outlined below, some users services took longer to fully recover. Perfect sense. It's just like the lingering inertia of failure just takes time to until all these failed requests just clean up, and then they are freshly being serviced again. In addition to fixing the underlying cause, we'll be implementing changes to prevent, reduce the impact of, and better communicate about this type of failure in the several ways. So what are they planning to do? Review our quota management automation to prevent fast implementation of global changes. So whenever there is a fast implementation of a global change, and what does it mean by fast? Right here, is it the 2 months period when they actually kicked in, or did they implement this quota management so fast as okay, let's just slam it in all, because we didn't see any errors, right? We applied it, no errors. But if that quota management actually detected that the service actually yelled at them, says, hey, this is 0. Again, guys, go back, right? They did not have an alert where things become 0. And to me, I mean, there's nothing you can do about this. It's just a missed alert. And how would you possibly think about all these scenarios? As humans, we can't possibly predict everything, right? No matter how much smart engineers you have, there is always some case that you will miss. And when that happens, catastrophes happen. This like this happens, right? So all you can do is that you have to be vigilant to understand the low-level fundamentals, what happened, right? And then work back to what you can do to solve it, right? That's why engineers have to understand what is exactly how things really work, right? No frameworks, no tools just does all the magic for you, because guess what? Yes, you have to do everything, right? Eventually, right? These tools will only get you so far, but you are building these tools. Improve monitoring and alerting to catch incorrect configurations sooner, right? What does it mean by incorrect configuration here? I mean, you have to define what an incorrect configuration means. I mean, we're not talking about syntax errors here, right? It's like you have to somehow sit down and come up with a write-up of all the possible invalid configurations, right? Like a usage of 0. It has missed. It's a human error. It's perfectly fine. You could not have possibly predicted this. So I gotta say, guys, I'm not slamming Google here. Google engineers, you guys are badasses to discover this in 20 minutes and solve it, right? And you could have not, there's nothing you could have done to prevent this. It's an error, right? I mean, how would you possibly predict that a usage could be 0, right? Now we learn. And you have generously decided to share this information with us. Thank you so much. Now we all know, right? That's why I don't blame any engineers. Like this, how the heck could someone predict something like this? This is just nuts, right? As a user, how it's like migration. This is a very tricky situation that you guys into, right? And this is a huge system. So of course, yeah, this thing is nuts. Nobody could have predicted this. Improve reliability of tools and procedures for posting external communications during outages that affect internal tools. Evaluate and implement improved write failures resilient into our user ID service database. Oh, so when the write fails to the user ID service database, they want to kind of make more resiliency there. So it's okay, a write to something as important as a user service database should never fail. They just like, hey, you know what? This should never fail. We know that, right? A write to a user ID, whether code or not, maybe give it a pass, right? But that's kind of dangerous, right? Give this service a pass, and what if this service turned evil? It will just eat all the user, all the code storage. That's like, these are tough decisions, guys. Don't think this is easy, by the way. These are tough. Improve resilience of GCP services to more strictly limit the impact to the data plane during user ID service. So they said, okay, GCP services should be a standalone from the user ID. So they are kind of trying to separate these two together, right, from each other, so that if one goes down, this shouldn't affect this. Right? That's what we saw with the AWS outage. When Kinesis went down, everything in Amazon went down. Everything, literally everything, because it was so key to Amazon infrastructure. Kinesis was a key, so that everything, including, ironically, the status report itself application, was relying on Kinesis. So if Kinesis is down, Amazon is crippled. Was crippled. It was really crippled for 4 hours. Was it 4 hours? Was big. So they have to make better decisions when it comes to this dependency tree that they have on Kinesis. I mean, people were just bizarre. It's like, even the customers was, okay, my Amazon services are down. What the heck is going on? They couldn't even see the outage service report to tell them that something is going wrong. They couldn't even open that page. That's when you actually, that's the worst scenario you could be, right? They are trying to avoid that, Google. So we saw that Google is not as bad as Amazon. Google outage, let's say, is not as bad as Amazon was, right? I mean, it was recovered in 47 minutes. That's just badass. We would like to apologize. Okay. Detailed description of the impact. Okay, let's read the detailed description. This is the last thing, guys. On Monday, 14 December 2020, from 3:46 a.m. to 4:33 a.m., so almost 47 minutes, credential issuance and account metadata lookups for all Google user account failed. Right? So if you're reading metadata about the account or credential, you're trying to authenticate yourself, these are failing. As a result, we could not verify the user requests were authenticated, right? That tells me that the request goes to a microservice that does the authentication and comes back and goes to the actual service, which says, who the heck are you? This is just a random request with no authentication. So, bam, it was failing. So the actual service that does the work, which is YouTube or other stuff, right? I don't know. Google Plus doesn't exist. Anything else, right? This was working, but we couldn't get to it because you're not authenticated, because the auth service, the user ID service, was down. And as a result, served 500 errors on virtually or authenticated traffic. It's like anything that's authenticated double code was just down. The majority of authenticated services experience similar control plane impact. Elevated error rates across all Google Cloud Platform and Google Workspace APIs and consoles. Products continues to deliver services normally during the incident, except where specifically called out below. Right? So they are going through the stuff that actually went down and the stuff that didn't went down. Most services recovered automatically within a short period of time after the main issue ended at 4:30 in the morning PST. Some services had unique or lingering impact, which is detailed below. All right, this is the last page. Cloud Console. The Cloud Console, any user who hadn't already previously authenticated to Cloud Console was unable to log in, as I described this in my early report. If you were authenticated, you had a token that makes sense that you should be able to access. But that gets you only so far because of the leader failure that we talked about, right? The expiry of the account information that kind of makes your account info outdated. That token will expire eventually, right? Users who had already authenticated may have been able to use Cloud Console, but may have seen features degraded. God knows, right? So like this service might use other services that just couldn't authenticate, right? Google BigQuery. During the incident, streaming requests returned 75% errors, while BigQuery jobs returned 10% errors on average globally. And this must have been scary. Google Cloud Storage. Approximately 15% of the requests to Google Cloud Storage were impacted during the outage, specifically those using OAuth, HMAC, or email authentication. After 4:30 in the morning, US Pacific, the majority of impact was resolved. However, there was lingering impact for less than 1% of the clients that attempt to finalize resumable uploads that started during the window. Gee, that is so good. Okay, this is interesting. So, if you have previously uploaded some content during the outage and you want to resume that upload, that failed essentially. Let's see why. These uploads were left in a non-resumable state. The error code GCS returned was retryable, but subsequent retries were unable to make progress, leaving these objects unfinalized. All right, this is pretty good. So if you have uploaded partially, right, you try to upload it, that state of the uploaded content is essentially corrupt because God knows you could not write certain metadata, you could not read certain metadata. So the write would have failed, right? And that gives you a partial upload that quote unquote resumable, but the metadata is inconsistent, right? Because you could not write all the information, like I don't know, the job ID or stuff like that, right? So now when you try to resume it, the Google Cloud will say, hey, you can resume this thing, but no, right? Because the state of the upload itself is just corrupt. So it was incorrectly reporting that is resumable, but if you try to resume it, you will fail. So that's when inconsistency really hurts. I remember some incident happened to me like a few years ago, like something like that. When something is corrupted, all bets are off. You have to kind of reset that state. Either in my word, I would disable and enable certain things that will just refresh that state. In this case, you're SOL. In my opinion, you have to delete that upload and re-upload it. But that's good. That kind of, I think in this case, they have to come up with a way to identify these corrupt uploads somehow, right? Either a tool or a verification or a way to repair. Maybe let's say if I uploaded like, I don't know, 200 gigabytes and all of a sudden you say, oh, I cannot resume that. That kind of sucks. It depends like how much Google wants to spend much time on this, in my opinion. But I think it's worth it. It's worth it. If I upload a lot of files, then the metadata inconsistency here is just like scary, dude. I still don't understand why this was an atomic operation, right? How did Google allow a write to go, right, after another write failed, right? So there was like a partial thing here. This is where all this what's called, the idea of having an atomic transaction when you write this, all of this stuff should go all in, or none of them should go, right? But what if you are in a distributed transaction, right? Distributed transaction is very hard to do. That's why people do this saga thing, right? The saga where you actually have events and, oh, if this failed, let me just go all back and do it. So something Google storage is not fully atomic, in my opinion. Something is effed up there. The networking control plane continued to see elevated error rates on operations until it fully recovered at 5:20 in the morning. So it took a little bit more longer. Only operations that made modification to the data plane VPC network were impacted. All existing configurations in the data plane remained operational. Google Kubernetes Engine. During the incident, 4% of the requests to GKE control plane failed. And nearly all Google managed and customer workload could not report metrics to cloud monitoring. They don't say why. How does Kubernetes has anything to do with the Google user ID? I never used the Google Kubernetes in Google. So do you guys, if anyone watching this, you guys use your Google account to create a Kubernetes cluster? If that's the case, maybe that would make sense. We believe 5% of requests to Kubernetes control planes failed but do not have accurate measures due to unreported cloud monitoring system. For up to an hour after the outage, 2% nodes reported conditions such as start grace period, again the start period, or network unavailable, which may have had an impact on user workload. Google Workspace. All Google Workspace services rely on Google's account infrastructure for login, right? So that they actually prefix this with a very nice statement here. They did not do this for Kubernetes. So they didn't tell us where Kubernetes cloud management uses the Google account infrastructure, right? So, but Google Workspace actually uses that. That makes sense. And enforcement of access for resources. You can access a document. That's why Google Drive were down for everybody, because that's the content essentially, right? You can't access anything, right? Now I'm asking, like, what if I shared this document publicly with everyone? If I have the link, would I will be able to open the public document that is shared with everybody? I'm guessing no, because there is some authentication that still need to happen. But Gmail messages, calendar events, all gone. As a consequence, all authenticated Google Workspace apps were down for the duration of the incident. After the issue was mitigated in 4:30 in the morning, Google Workspace apps recovered, and most services were fully up by 5 a.m. Some services, including Google Calendar and Google Workspace Admin Console, served error until 5:20 in the morning due to traffic spiking following the initial recovery. That's exactly what I said a few minutes ago, right? As this traffic keep piling up, right? This will eventually time out, right? Because you can't possibly serve hundreds of million of requests at the same time. So with a service so small, just purely infant service, just spun up and just recovered, you can't possibly serve all the load, right? It's not magic, guys. It's all theory and computer science. It's all engineering. You have to have enough instances to serve all these requests. So yeah, initially those requests will time out, and they should time out, and they should be canceled, so that you can start spinning up more services, so that new requests will just pick up new services. Some Gmail users experienced errors for up to an hour after recovery due to caching of errors from identity services. All right, so that's why I hate caching, man. Like, the other caching layer on top of the user service cache the fact that the account information is unavailable, and it kept serving that information that the account is unavailable to its customer, to its client, despite the service being unavailable. So the right back cache probably did not kick in, essentially, right? It's like I don't think any write back or write through would have saved you from this disaster. So the service should periodically check if the cache is still valid by periodically re-logging, right? And then try, oh, is the service up? Is the service up? Is the service up? So that probably took an hour until this actually got down. So that's actually very interesting if you think about it. And there's lessons for us to learn here. What if the backend is down and you have a cache in the middle and you have a write through cache, right? Read and write through cache. You ask the cache, and the cache asks this backend, and the backend is down. How long would the cache should keep trying to ping, again, poll the backend to retrieve the actual original status? That's a tough question to answer, in my opinion. Let me know in the comment section, guys. What do you think? What would you do in your situation? I'm just curious to hear your opinions. And final thing, cloud support. Cloud support internal tools were impacted, which delayed our ability to share outage communication with customers. Okay, so they did have the same problem as Amazon did. Not as bad, I guess. Which delayed our ability to share outage communication with customers on the Google Cloud Platform and Google Workspace status. Customers were unable to create or view cases in the Cloud Console. Well, that makes sense because to create a case or view a case, you need to be authenticated. They shouldn't be able to view. They should be able to view cases without login. Come on, right? I mean, maybe they require an authentication. So if you require authentication, you will fail. You cannot create cases. But a public status public dashboard should be available, a static HTML page, right? We were able to update the customers at 5:30 after the impact had ended. Well, that sucks. Oh, no wonder you guys were confused. Like, okay, what is going on? Google's not, and Google's not saying anything. Okay, so apparently Google had the same problem as Amazon for over an hour, or maybe 2 hours. Wait a second. They started at 3:40, right? It's 5:30. It's 2 hours. Customer didn't know what's going on for 2 hours. So maybe the cloud service they tweeted or something. Must have someone must have tweeted, or some static page, right? What is the page we're on here? Does this require authentication? Definitely not. I'm not authenticated. This is an incognito mode, right? So they must have essentially just published this publicly. All right, guys, what do you think about this incident? This was an interesting, right? And apparently we have some lessons to learn from this. And they actually ran the same problem as Amazon did. They could not notify the customers because the incident report case required an authentication, which relied on authentication service, which was down. So you couldn't even create a case. I mean, how would you go around that? I have no idea. You make this public, I guess, but you cannot let people create public cases, right? That's why where down detector and services like that comes in handy. Guys, what do you think about this outage? Let me know in the comment section below. And I'm gonna see you on the next one. This was an interesting one. We learned a lot. And again, guys, I don't think what Google's trying to do here is the maximum they can do, right? As a mitigation. I can't think of a way to prior to think about what could have happened, or I mean, I can't think of how you can predict that the usage can go to zero. It's like this is something that the usage can never go to zero. So that's why you check if the quota is less than the usage, then you check that. That's a obvious check. But how do you check that the usage is zero? The usage will never be zero. To them, maybe a zero has special semantic. I mean, I do this all the time. I assign, if something is impossible, like a usage, because a service must have used at least one byte, right? So I know that a service will never be zero. So if it was me, I would have assigned some semantics to the value zero. And maybe this is what happened here. It was like, oh, user should never be zero. So zero might have meant something else, or might have meant anything. Might have meant nothing. Who knows? All right, guys, that's it for me today. Hope you enjoyed this video. Next up, I am going to take some time to do the solar wind report. That one is nasty. That one is just not as just clean as as this one, where we have one report that kind of summarize everything, right? So I'll need to go through the Firefly. Is that Firefly? Fire Eye, Firefly. Or the fire that Firefly was a show, I think. Yeah, Fire Eye and a report and go through that and watch some videos. I watched the Steve Gibson Security Now video, but I'll keep reading more about that, and we'll let you know, guys. So follow me on Twitter if you want. Keep up to date and send me those beautiful articles whenever you see something interesting. Keep send it my way. I'm gonna see you on the next one. You guys stay awesome. Goodbye.